Telescope is upsetting the apple cart.
You won't believe what Michio Kaku found with the James Webb Telescope. You may be surprised to find that powerful individuals like Michio are fervently convinced that life is thriving on distant worlds in the universe and possibly even within our own solar system. But this most recent finding calls into doubt both the origin of the universe as a whole and all we know about the formation of galaxies. What exactly is this shocking new finding found by the James Webb Telescope on Proxima b, and why are scientists more confident than ever that it could alter how we live today? Welcome to Space Gateway, the channel where you can find the latest information about space. In today's video, we will see what Michio Kaku found with the James Webb Telescope. Let's get into it. The James Webb Space Telescope of NASA has observed the atmosphere of a hot, puffy gas giant planet that is orbiting a distant star that resembles the Sun. The observation, which relies on minuscule variations in the brightness of particular light hues to infer the existence of particular gas molecules and bears the distinctive signature of water as well as signs of clouds and haze, is the most thorough of its kind to date and emphasizes Webb's unrivaled capacity to study atmospheres hundreds of light-years distant. The Milky Way has more than 5,000 known exoplanets, including WSP-96b. It is a particular class of gas giant that is located in the Southern Sky constellation, some 1 to 150 light-years away, and has no direct analog in our solar system. Phoenix WSP-96b is the puffiest planet in our solar system, with a diameter 1.2 times that of Jupiter and a mass less than half that of Jupiter. It is also hotter when the temperature hits 1,000 degrees. Every 3.5 Earth days, WSP-96b completes one full circuit of its Sun-like star, orbiting it at a distance just 1/9 that of Mercury's orbit around the Sun. The transmission spectrum reveals details of the atmosphere that were previously concealed, such as the undeniable signature of water, hints of haze, and evidence for clouds that were previously believed not to exist based on observations, while the light curve confirms characteristics of the planet that had already been established from other observations, such as its existence, size, and orbit of the starlight that is filtered by a planet's atmosphere. In order to produce a transmission spectrum based on the absorption pattern, the starlight that is seen when the planet is close to the star is compared to the starlight that is seen as it passes in front of the star. Water and other crucial substances similar to oxygen, methane, and carbon dioxide, which are not immediately visible in the WSP-96b spectrum but may be viewable on other exoplanets slated for investigation by the Webb, are extremely sensitive to this region of the spectrum. The spectrum will enable scientists to determine the deep average temperature of the atmosphere, put limitations on the abundance of certain components like carbon and oxygen, and quantify the amount of water vapor in the atmosphere. Due to Webb's innovative design, the known characteristics of WSP-96b and its star, including size, mass, and temperature, as well as the assumed characteristics of the atmosphere, the clarity and detail of the measures are astounding. Its 270-square-foot gold-coated mirror efficiently collects infrared light. Its sophisticated spectrographs split light into hundreds of infrared color rainbows. Additionally, its extremely sensitive infrared detectors can discriminate between brightness differences in the slightest shifts in light. Differences in hues and colors that are only a few thousandths of a micron apart. Before continuing the video, subscribe to our channel and click the like button. Also, enable the bell icon for more exciting videos like this. Moving on. The groundbreaking project announced in 2019 that they were funding the telescope for orbit locus interferometric monitoring of our astronomical neighborhood, Ptolemy, which was given the star's old Arabic name. The aim of this low-cost mission proposal, created by a team from the University of Sydney in Australia, is to employ the astrometry approach to look for potentially habitable exoplanets in the Alpha Centauri system. In order to do this, one must look for signs of wobble, which indicate that gravitational forces like planets are affecting a star's apparent position in the sky. The stellar system Alpha Centauri is composed of an orange dwarf secondary star and a G-type parent star similar to the Sun. Due to this system's dual nature, it has proven extremely difficult to discern potential signals from the system that could be brought on by exoplanets. However, in 2016, the same method was used to confirm the discovery of Proxima b, a rocky planet orbiting within Proxima Centauri's habitable zone. Around Alpha Centauri, a prospective planet known as Possibility C1 was found in 2021. The mission's chief scientist, Peter Tuthill, a professor of physics at the Sydney Institute for Astronomy, can't resist taking on the difficult task of confirming the presence of planets close to Alpha Centauri A and B. Instead of focusing light into a focused beam like standard telescopes, the Ptolemaic system uses a diffractive pupil mirror design that scatters sunlight into a complex floral pattern, allowing for very accurate measurements of a star's velocity. The search for evidence of exoplanets can then be conducted using more powerful instruments that are not limited to monitoring Alpha Centauri. The James Webb and other next-generation observatories, such as the Nancy Grace Roman Space Telescope, would carry out this follow-up investigation. Alpha Centauri is also anticipated to be a popular target for the numerous 30-meter ground-based telescopes that will enter service this decade. EnduroSat has an agreement with the University of Sydney to provide a specifically designed small satellite as the delivery system for an ongoing observation mission that will require several data downloads. Their microsat configuration can downlink payload data at a rate of over 125 megabytes per second. One of the initiatives funded by Breakthrough Initial, which is already having an impact with its cutting-edge initiative Breakthrough, is this most recent endeavor. The Ptolemaic project, the largest program yet mounted in the search for extraterrestrial intelligence, is also compatible with the projected groundbreaking Starshot interstellar mission, which would send a nanocraft to Alpha Centauri within a single lifetime. Finding nearby planets will likely be a major motivator for interstellar trips to further investigate the system in 20 years because of advancements in miniaturization, advanced materials, and directed energy propulsion. Now, obviously, we can go on speculating here, but we'll leave it there and end by asking the question, what do you think about this new discovery? Drop your theories in the comments section. Remember to subscribe to our channel for more interesting content. We will see you in our next video.